Hello, everybody. It's me again. We're back. I haven't been working on the channel for some time, but it's nice to be back. I always enjoy spending some time on the channel, adding some content. And please, boys and girls, please like, subscribe, share the videos, share the content, let it play. It does mean a lot to me. Anyway, in this particular video, what I'm going to do is something completely different than what I've been working on since the beginning of the channel. About two months ago, one evening, I was watching some YouTube and I found a video on the Enigma machine. Now, I had no idea what the hell the thing is, and so I spent some time watching some videos, reading up on it. I found it to be absolutely amazing and captivating and interesting. Um, so as I got to know the ins and outs of the Enigma machine, the importance of it in World War II, I thought, can we do that in Excel? Can I replicate the Enigma machine in Excel? And so that's what I'm going to spend some time on, is to show you what I've done in terms of creating the Enigma machine in Excel. Now, for those that's not in that's not a doesn't know too much or anything about or first time hear about the Enigma machine, there's lots and lots and lots of on YouTube. But essentially, let me go there. It's a machine that looks like this. It looks like a typewriter, old typewriter. It's got the keyboard, QWERTZ. It's in German numbering, so it's not American or Western numbering, but it's your normal keyboard as you would have with your laptop, your computer. Except it doesn't have the ones and twos, the numbers, it's only the letters. So it's got the keyboard. So this is where you press a button. Then what it does, it's an encryption device, by the way. It's an encryption device. It was used by the Nazis in the Second World War to send to do all their communications. So to especially in terms of directing the U-boats to attack the convoys that were sending replenishments from America to the UK. And so what the Germans wanted to do is to starve basically the English in terms of their submission into World War II. And what kept the British alive was this constant fleet of ships transporting goods and services, provisions, equipment, etc., from the US to the UK. So the Germans deployed U-boats in wolf pack formations, and they would direct those wolf packs via the Enigma machine to hunt and destroy these merchant vessels that were shipping all these provisions. So it played a huge role in the Nazi war effort. And so yeah, so that's the keyboard. Okay, it's just normal. You press basically it runs through electricity, through current. This is the battery. Okay, you can see there's the battery, and this is the light board, the lamp board. And so what happens is, let's say you press a P here, you press this P button down, then a lamp will light up, and that would be the encrypted letter. So for example, let's say you press a P, and then the lamp at V will light up. So meaning the P letter has been encrypted to V. So you type in a message, and what comes out is what they call gibberish, just letters. And the English couldn't decipher this, so they created a unit at Bletchley Park to decipher the Enigma machine, and it took quite a lot of turns and flows, ebbs and flows, for them to decipher the Enigma machine. But anyway, because it has something like 154 million options. So P can be deciphered into 154 million options. I think, yeah, I think that's the right numbers. Anyway, so you've got a plug board, you press a button, and then a corresponding letter in the LAN board will appear, and that's the letter that will then be, that's the encrypted letter that will be then sent via Morse code to the U-boats. So what happens is, let's say the P is pressed, it runs through this plug board. The plug board, you can change the letter. So you can change P to any letter here. Let's say, or it can stay itself. There's 10 options here, and it's done through these cables. Anyway, so P is pressed, it runs through the plug board. It can be changed here, let's say, to E. So P can be changed here to E, or it can stay the same. Then it runs to the rotors. There's 3 rotors here. Now the Germans had 5 rotors. So they can choose any 3 rotors, and obviously also the numbering of the rotors. And each of these rotors has 26 wires. So each router has a wire. So the letter P, it's encrypted to E. It runs through the first router, and let's say the E is then encrypted to Q. From Q, it runs to the second router. Let's say it's encrypted to W. And from W, it runs through the third router. It's encrypted to S. So now it's encrypted once, twice, 3, 4 times. Then there's a deflector, meaning it makes a U-turn, and then it comes back. So then let's say the S goes into the reflector, it comes back, and then it goes back to U. U gets encrypted to Y, Y gets encrypted to S, and then it comes back to the plug board, and let's say it goes to S here, which is then encrypted to A, and then A, the light bulb of A will light up. So it's encrypted once to the plug board, twice to router, third router, fourth router, deflector, back to the third router, back to the second router, back to the first router, back into the plug board, and then into the LAN board. Okay, so that's quite a complicated system. Now, what's making it interesting is that, as I said, these routers is one of 5. So every morning or every night, 12 o'clock, the plug board gets reset, the router choice gets reset, meaning, and then the router location gets reset. And then also, these routers have a stepping machine, like your stepping mechanism, like your odometer. So every time you press a button, the first router moves 1 position. After 26 rotations of the first router, the second router moves 1 position. After 26 movements in the second rotation, the third router moves 1. So it's got a stepping mechanism. So that made it very, very, very difficult to decipher because of the millions and millions and millions of options. Okay, so the keyboard, as I said, is a standard keyboard. Nothing to it. This is a more later version that included some numbers, but the older version had no numbers. And I said it follows roughly the Western layout with some differences because obviously it's in German. So that's your keyboard. Then we have the plug board, which is this thing here. And you can say we can change the letters. Let's say from F in this case goes to J. So if you press the letter F on the keyboard, it will come out as J, and J will then be moved into the rotors. And when it comes back, let's say it comes back as O, then it will go back as S, and S will then be the letter that goes up into the LAN board. So it's an out and an in where you can change. If it's like R, so if you press R, there's no change in R, then it will go to the routers as R. Okay, so yeah, so that's just the makeup of the plug board. It's got all the alphabetic letters, and as I said, you can swap up to 10 options. You've got 10 cables. Why they just stopped at 10, who knows? But yeah, that's 10. Then the routers, as I said, there's the routers. It's You can see it's got the stepping mechanism like your odometer, which is this. I'll show you now how that looks. And it's got 3. Later versions actually included a 4th rotor as well. I said there's 5 rotors. Each rotor has its own wiring mechanism. And then, as I said, this could be set. And then every night at 12 o'clock, they will give the starting position of these rotors. So there's quite a lot of flexibility in terms of the rotor, and I said it works with current, electrical current. So all these things are connected. So it goes through the first rotor, goes to the second rotor, goes to the third rotor. I said then it goes to the reflector and comes back to the third rotor, second, and I said there is 5 rotors. So it's the position of the rotors, it's the rotors that you select, it's the ring settings, and its initial position. So there's quite a lot of flexibility in the stepping. I said there's a stepping machine. You can see there's a stepping machine there. So I said the first rotor is every time you press a button. The second rotor is every 26 times the first rotor. So it makes a full rotation. And when the second rotor makes a full rotation, then the third rotor steps up. So it just pushes the rotor up every time it affects. Then the reflector, that's the end. There's also was one of the main drawbacks because the reflector basically it makes that a letter can't be itself. So if you press P, it can't encrypt to itself. So that was one of the major issues with the Enigma and how they to some degree decipher it, because a letter cannot encrypt to itself. A S cannot become a S. If you watch some of the videos and stuff, you'll see what happens here. So that's the reflector. Then you have the LAN board, etc., etc. And this is basically just the encryption as I suggested. You press a button, let's say W. W becomes in the plugboard, goes in, becomes a D. It goes in rotor 1, rotor 2, rotor 3, deflector, goes back to rotor 3, rotor 2, rotor 1. It goes back into the plugboard. Plugboard got changed to Z, and Z will then be the light. Okay, so that's basically, so it gets encrypted once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. Okay, so letter gets encrypted 8 times if it's changed in the plugboard. Okay, so there's another one. So I hope you have plus minus understanding of the complexity of the Enigma machine and why it took such a lot of effort to decipher it. And it's by pure luck sometimes, in most cases, that they decipher it by founding what they call, because the Germans changed it every night at 12 o'clock. So they had these sheets that they were supplied that included the monthly settings of the Enigma machine so that everybody is on the same page. Anyway, so here's the spreadsheet. So this is where it becomes fun. So here's the spreadsheet that basically is the Enigma machine. Okay, so here's your keyboard letters. Okay, there's my rotors. And then there's rotor 1, rotor 2, rotor 3, rotor 4, rotor 5, and the reflector. And each has its wiring, meaning each has different wires. So they're not all alphabetically. So rotor 1 wiring is F, A is F, B is P, etc., etc. Rotor 2, A becomes M, and rotor 3, A becomes T. Rotor 4, A becomes F, etc., etc. So there is the internal wirings of my rotors. Now this is randomly generated in Excel. Okay, this is just randomly generated in Excel. They're all different. Okay, so there's my rotors. So there's my keyboard. There's my 5 rotors. There's my 5 rotors wiring, meaning its encryption. And there's my reflectors wiring. Okay, so there's my, okay, so before I do anything, there's my steps. Rotor 1 step, rotor 2, rotor 3 steps. There's my plugboard. Okay, so in this case, A will become H. Okay, B will become I, K will become A, F will become G, I become E, J, L becomes J, S become K. The letters like C will stay C, D will stay D, etc., etc. Here's just checks to make sure that there's no repeats here. Okay, you don't want A and then an A here as well. You want all of them separate. And this check is to make sure that the two pairs are not, you see the two pairs are not in error. Okay, just to make sure that our plugboard is correctly, and they're all by drop-bound boxes. Okay, so that's just to make sure our plugboard is working properly. And there's no errors in the plugboard. Okay. Then, as I said, what we need to do is to select our routers, router selection, and our router selection specifically from router and also the position of the router. So this will be our first router, and in this case, our first router will be router 5. In this case, our second router, the second router will be router 3. In this case, our third router will be router 1. Now we can choose any of 5 routers there. That's why we've got the 5 routers. So I can choose router 5 there. I can choose router 2 there. Whatever router I want to choose. We had router 5 there. And again, I can make that router 5 and that router 3. So I can play around with these routers, but here is the router selection and the router position. Okay. And here is the starting position of each router. So in this case, that specific router, my first router, in this case router 5, will have a starting position at A. Router 3, which is my second router, that router will have starting position Y. And my third router, which is router 1 in this case, will have a start position of position 5. So those are the important ones that I need to do. What is my plugboard settings? What is my router settings? And what is my router positions? So that is what we start with. Okay. Then, as I said, we have these tables, which are our initial alphabet, our plugboard, our keyboard, sorry, and we have our router wirings. Okay, so those are important things that we have to do. Now, what happens now is that router R, okay, so let's start fun. Let's say I select a letter, let's do S. Okay, so I'd select letter S. So that indicates here in red, this letter that I've selected is S. Now what basically means here is now my router 1 will move one step forward. Okay, now this letter S, if we look at the plugboard, there's my letter S there. It gets encrypted in the plugboard to K. Therefore, the plugboard outcome letter is K. Okay, now let's have a look. Now let's go back because it would have moved the routers. Okay, so let's keep it there. So K. So now what we need to do is Excel now needs to figure out the order of my routers. Okay, so now what I want is this column here. I need Excel now to from this column enter here the first router and its wiring. Okay, so you'll see it will automatically, it's with if statements. Okay, so if I press router 5 here, for example, router 4, for example, it will select router 4 here and its internal wiring. So here I select router 5 and it selects. So here I've got router 5, router 3, router 1, which is my router selection, my router and its position. Okay, so router 5, router 3, router 1. So if you look at router 5 there, that is router 5 OZU. There's OZU. That's the internal wiring. So the S will go for the plugboard. It will come out of K. And then K will go into router 5. So I find K and it goes into router 5. So why is that router? Okay, sorry. Now it goes S. Yeah, S. Okay, so let's quickly just do this. Where was it now? Let's do S. Okay, so S goes into K, and at the far K, this K becomes D. So why is it doing that? Why is it giving me a... Okay, sorry, I missed one step. I missed one step. I missed the initial starting position. Sorry about that. So here, what I'm doing here is selecting rotor 5. So that's my first rotor, first position. So rotor 5 will be my first rotor in the first position, so I duplicate it here. Okay. So there's the 3 rotors, which represents this part here. But now remember, I've got a starting position. So I need to take rotor 5 and make A the starting position, not O, which is in this case the starting position, but A. That must be my starting position. Okay, so now I create a second set of tables. You see, so now I take this table, okay, and I make A the starting position. So I move this up and take this below that. So you'll see A, V, and then G will be there, and then G will become O, and it will end with X. Will end with X. So there's my starting position. Okay. So the first is the wiring of each router. Then I select the routers and their positions. Okay. And then I changed each router to its initial starting position. So the first router, which is router 5, will have a starting position of A. So I make A must become the beginning value, so it swaps around, but in the same order. The second router in my case is router 3. So that's the second router is router 3. Its starting position is Y. There's Y, which is Y here. Where's Y? There's YQD, YQD, and it ends with N, And my third router, which is router 1 in this case, there's router 1, has a starting position of P. There's the starting position of P. So that is what that set of tables and this set of tables do, etc. etc. But now remember, okay, okay, so that's going to be now 0. So therefore, this is my stepping mechanism. So in this case, there's no stepping, so this will be exactly the starting position table, and the stepping mechanism table is exactly the same. But now what happens when I change, if my router moves once? Okay, so now let's have a look here. So that was A. Okay, that was the start. Remember, that's the router initial wiring, the original router wiring. Then it's at a starting position, which is A. So I shuffle this wiring so that it becomes A, V, M, etc. in that order. Now it has a stepping mechanism. So the next one, it's not A that is the starting mechanism, but V. That's the starting mechanism. You'll see it has, so that's the initial. So I press a button and it steps up. So now V becomes the starting position and A becomes the end, etc., etc. So I hope that makes sense. So that's building these tables, which basically takes into account the router selection and the router position, the initial value of each router, and then the stepping mechanism. So that's all built in tables using various formulas to move, etc., etc. Okay, so hope that makes sense. Anyway, if you read about the Enigma machine, you'll start to get understanding. So I did it all using tables. So, okay, so let's go for an example. So let's use Z. Okay, so I use Z. Yeah, I use Z. Now it's run through the plugboard. So there's Z. So that gets now encrypted to D. There's my D. Okay, so Z, I've selected Z. Because I've selected Z, router 1 moves one step. Okay. Z here becomes D. Okay, you'll see there D. D in this case runs now through router 5, which has initial position of A. Then it runs through router 3 that has initial position of Y. Then it runs through router 1, which is initial position of B. So it runs through the last set of tables. So D, okay, there's the last. D becomes B. Let's have a look. D becomes B. B becomes Q. B becomes Q. Q becomes H. Where's Q? Q becomes H. Okay, now it's run through the 3 plugboards, the 3 routers with the initial starting position and router 5 one step. Okay, now it goes through the deflector. Okay, now it goes through the deflector. H will go to the deflector. And what will H become? H will become W. So H becomes W. Now it goes back to the reflectors, but in reverse order. So W that came out of the deflector, W, in the deflector becomes G. Becomes G. And G in the third reflector, which is router, third router, which is router 1. That becomes then, sorry, where router G becomes router C in the third. So G becomes C, and C becomes F. And then it goes back into the plugboard, and there's no F here. Yeah, F becomes G. F becomes G, and G is then what is in the LAN board, and then that is the encrypted value. So Z here becomes G. Now let's just say Z becomes G. Now what is important is the stepping mechanism. So for example, if I select Z again, because of the stepping mechanism, it shouldn't repeat itself. So now Z, I've selected Z again. It's router 1 now, steps 1 place forward. So therefore, Z cannot encrypt itself to G again. So now, in this case, Z becomes B. And that's the beauty of the stepping mechanism, that the letter won't repeat itself, encrypt itself, repeat. And that's what made it also very, very difficult. That's the importance of the stepping mechanism. If it wasn't for a stepping mechanism, if Z becomes G, then Z will be G in all of it. But now Z is G here Z is B. If I do Z again, then you'll see Z becomes Z. That is impossible. Shouldn't be able to do that. I think there's a little issue here. I think it's this reverse plugboard where is the problem. I need to swap it. Anyway, I'll update it and get it correct. But you'll get you get the understanding of what's happening here. So that's the importance of the stepping mechanism. Now, if you'll see here, so let's do it over and over again until it's 26 times. So let's make it 25 here. 25. If I go now H, it will see 26. Now the second router moves 1 position. If I go on D, you see it still stays until a new 26, and then that will go to 2. If this becomes 26, that will become 1. Now that's important because you'll see that if you look in this, it will have C4, which is its position. So it is plus that position. You'll see that one is D, and that one is E, so which corresponds to C, D, and E. So let's just delete those 2 again, and there we go. So again, D. So if we select D, D will stay D because it's not in the plugboard. You see, D will stay D because it's not in the plugboard. Let's now change the router position. So router 5, let's go router 3, router 1, and router 4. So you'll see that is now our router selection and our router position. You'll see there that it reflects it. So now our first router is router 3. There's router 3 and it's wiring TZ, router 3, TZ. Starting position, let's change that now to K. So our first router is router 3 and its starting position is K. So there's our first router, which is router 3, and its starting position is K. It's where's K here? Let's have a look. There's K. So it's KHI, KHI, and it will end with WO. It will end with WO. There's the one step. It's exactly the same because there hasn't been a step itself. But if I were to make that one now, you'll see that it will step from K. H will now be the beginning. H will now be the beginning there. So you see this is fully automated. I think the backward one there's an issue with that. I need to fix it. That is an issue there because it shouldn't be able to encrypt itself. So that's a little issue there that I have to resolve. And I think it's just because I've got these two. The reverse one should be from this to that one, where I have it from B to C. It should be from C to B. Yeah, so that's the Enigma device. And it's all automated. So if I press this, it will run. It will, yeah, as I said, the ones in black are the options that I need to change. And as I said, what happened is that they had a sheet, the encryptors. They had a sheet for the month, first day, second day, third day, which indicates the router selection. It indicates the router positions. It indicates the starting position of each router, and it indicates that the plugboard. So all these three things, that's in black are what needs to be selected. The rest, it runs because the wiring that comes with each router. Okay, that comes built in with each router. So that could not be changed. And that's the Enigma machine in Excel. I said, I just need to change this thing. It needs to be in reverse order. But otherwise, that's the Enigma machine. As I said, in Excel, it's built by a significant amount of formulas. And with the stepping, it's actually built by code, a little code. So you'll see there, there's your selected routers in its positions. And it says there that router value plus 1. Router 2 is 26, then it will go plus 1. Router 3, it's 26 plus 1. Okay, so every time there's a router change, then yeah, that's how we made the stepping mechanism. There's no formula for that. So the only is using this worksheet code that one can use to affect the stepping mechanism. Yeah, so that's what the stepping mechanism. This is this part here, which is a stepping mechanism. So every time I'll press a button here, then that will go move one step forward. Every 26 full circle, then the second router full circle, 26 movements. The third router will be. And so that's a plugboard. That's just checks to make sure. So for example, if I select the I here, it will give me an error to say you cannot have the same one here. Okay, so if I change that to A, why is it giving me, it shouldn't give me, it should give me an error as well. I need to just change this. Yeah, I need to just change this so that also it doesn't, it's supposed to give me an error It should be a B, and that should be a B. And now if I change this to A, it still doesn't give me an error. Anyway, it's supposed to give me an error, so that's a little glitch that I just have to sort out. Just to make sure that there's no doubles here, so there's no B here. And let's say if I make a B there. Okay, so that gives me an error there. Okay, so that's, but it's because these two are B's. So let's make that a K. This is supposed to be now a error. You see, it's supposed to be an error. Not good. It's supposed to be an error. But anyway, I'll sort that out as well. But yeah, so I've built in these checks to make sure that my plugboard is correct. Visually, you can obviously do it, but just to make sure. So what's next is to do a full encryption, because now I do it word for word for word. So what I want to do is press D, get the letter, encrypted letter, press whatever. So let's say I say this is Friday. So I'll do F, I'll do R. So I'll build the Friday, the word. I'll type Friday in the word, and then the full outcome will be here, not just the encrypted letter. So the full Friday. So it will be Friday. Okay, so let's go back. So if I do, let's go clear it again. So I'll do Friday. So I'll do an F. F becomes a M. And then I'll do Friday with R. R becomes L. I becomes C. And D, what with D becomes W. And A becomes N. And Y, Y becomes H. So Friday, let's make it a bit nicer. Let's do this just for interest sake. So Friday becomes MLCWNY. So that becomes Friday. MLCWNH. So that will be the gibberish. So now you send that by Morse code, MLCWNH, and that will encrypt to Friday. So now people will know it is Friday. So MLCWNH will be, that Friday will be encrypted to that, and the guy that receives this message, MLC, will type it in reverse order and Friday will come out. But we'll do that in another video. Let me just fix one or two of these problems. So that's Enigma. That's Enigma. So that M is encrypted from F, running for all the systems, etc., etc. And obviously the keyboard moved 5 times. 1, 2, 3, 4, and 5. Okay. So that is the Enigma machine, the basics in Excel. If I change it, so interesting, if I change this now to rotor 2, and I start all over, and I do an F for Friday. Where's F? F in this case becomes R, etc. So you'll see it, and if I change the starting position, C, then it becomes H, and so on, so on, so on. So F could become a M, could become a R, could become a H, all depending on the starting position, the rotors, the plugboards, etc., etc., etc. You can see the complexity of the Enigma machine. So, well, let me continue working on it. It's got a seemingly a couple of gremlins. Let me fix the gremlins. And then I'll come back and do a video, and then also trying to encrypt full words and do the reverse encryption. So yeah, something fun to do, interesting to do. Test your abilities on Excel, and as I said, it's fun to see these things come together. Yeah. So yeah, something different, as I said, totally different to my normal videos, my normal focus. But yeah, it's a nice challenge. I challenge myself, and figure it out, how to do it. And it's very, very satisfactory to eventually figure this one out. So yeah, that's the Enigma machine. So with that, let's end it. But before, please like, subscribe, share my videos, play around with my channel, put it at the back burner, just let it run in the background. Doesn't cost you anything, and it does mean a world of good to me. I really appreciate it. So thanks for all your loyal supporters and followers. I really appreciate it. And with that said, I'll see you on the other side.